to begin. This is the last session for today of the Waste Summit, a very interesting topic, and today's moderator is Sebastian Frisch. So Sebastian, how about you turn on your camera?
Yes, hello, Christoph. Hello, everyone.
Yeah, I would say the screen is yours.
Thank you, Christoph. Yeah, it's a pleasure to welcome you all to this session named Innovative Recycling Technologies and Suitable Financing Tools. My name is Sebastian Frisch. I'm a process engineer. I'm working since about 20 years in the field of waste management. I'm currently based out of India, and I've also traveling a lot to Southeast Asia. And I'm very much looking forward to this session today. We are glad that we have four experts with us. That's Mr. Massimiliano Tropeano from GIZ, Ms. Katherine Chan from the Hong Kong Research Institute of Textiles and Apparel. And we have Mr. Sajith Edirisuriya from Mong Ecocycle, and Mr. Rolf Keil of EUWELLE. They will be presenting us their view on either innovative recycling technologies or suitable financing tools. I will also close the presentations by one perspective or view on suitable financing tools. And in the end of the session, we will also have a chance for a question and answer round. If you have any urgent questions in the meantime, also please feel free to use the chat function. And in any case, we would be glad to have a lively and proactive discussion at the end. Looking forward to your questions and to your participation. So without further ado, I would like to give the word and the floor to Mr. Massimiliano Tropeano of GIZ Cambodia. Thank you. You're still muted, Massimiliano. No, still.
Can you hear me?
Now yes. We can hear you, yes.
You can? Okay, great. Thank you, Sebastian. I hope the Friday afternoon is not going to get too long. I will try to be a little bit quick, but very, how to say, concise. Good. Let me share my screen. Can you hear me well?
Yes, we can.
Okay. Can you see the sharing screen?
Yeah, we can also share your see your screen.
Perfect. Can I ask everybody to switch off the camera, and I can ask the people participating to go with the mouse around the green area and click on view option side by side. That will give you, I guess, the best experience in terms of webinar. Well, my name is Massi. I work for GIZ, and particularly I work for a project that is called Fabric. Fabric, as you can see from the presentation, aims at promoting sustainability in the textile and garment industry in Asia. It is actually a regional project, very quickly into it, that encompass 6 countries, and would like to have to be an umbrella and a connection between private sector, local production company, business association, ministry, trade unions, and civil society. Of course, we do many things across the region, but I have selected a few of them, very few of them. We have an empowerment house in Myanmar, in Cambodia. We work with the UNFCCC for the global climate action. We do training on chemical, water, energy, solar panels. We work in the transportation and wash, etc. One of the main topics that recently we got into in terms of environmental sustainability is, of course, the waste, and particularly the waste generated by the fabric, by the garment industry in Cambodia, and not only in Cambodia. So it's a pretty recent, and we decided to start with a fabric waste study, particularly technically speaking, post-industrial fabric waste in the garment sector in Cambodia. The results were pretty interesting. This morning, Jérôme was talking about textile waste in general. And these are the results. Basically, as you can see, the big blue square over there is a textile waste. That is industrial waste in Cambodia is 60% made by textile waste. So Jérôme was talking about 9.5% of textile in terms of total volume of waste. But when you narrow down into industrial waste, that percentage skyrocket to 60%, essentially because the garment sector is the only one organized in Cambodia. And if you combine the 60% with the 10% of leather scraps that we have over there, leather and leather products, let's say, we have a 70% plus composition of the industrial. So it was obvious that we wanted to address the issue of the post-industrial fabric waste. Hello? Yeah, maybe not everybody knows that between 5 and 20% of the textile that is used into the production of garment actually ends up in as a waste directly in the bin, because all the garments are shaped in a way that all the scraps are just discarded. We found out that a quite high, significant portion of this gets burned or gets disposed into illegal landfill, especially in the last 1 or 1.5 years. The best portion actually gets exported. Now, what we try to, when we try to understand how much of this actually gets disposed in an illegal manner, we found out something pretty interesting. There's a huge difference between the fabric waste generated by the industry and the fabric waste, that 60%, that is collected by an organized company, let's say Sarom in the countries, which is the only one actually authorized for industrial waste. Perhaps there are a few more, and the SEZ are organized, few SEZ outside Phnom Penh are organized in a different manner, but mostly is Sarom. So basically we found out that the difference accounts to approximately 86,000 tons that either get burned or either go disposed illegally or gets exported or goes into a small stream of recycling that is unorganized, and above all is also, how to say, a niche, goes into niche product. So there is a well-established gray market into this entire story, and the ban of garment of waste import from China in 2016 had a big impact onto this, onto the volume of waste. And another issue that we found out is that the taxation related to the waste actually has a huge impact onto the behavior of the garment factories. To give you an idea, all this, when I import some fabric, I import it duty-free, and the same amount of fabric in theory should be leaving the country to be classified as duty-free, where the factory doesn't pay the duty. But if 10% of that fabric gets sold into the system, into the country, into the kingdom, actually the entire lot of the fabric attracts duty. So it is obvious that such a policy invites the entire garment sector to have a sort of gray market where where the trade of these scraps and piece of fabrics are actually either illegally exported or illegally burned or recycled in a small manner. Anyway, for whomever wants to have more information and the entire report, we have put it into our big hub that is called Asia Garment Hub. There is a link in the presentation. We decided to dig deeper into the region with this fabric waste study, with a sort of regional study, with encompassing Vietnam, China, Bangladesh, and Pakistan, because most of the country that I named and the entire Southeast Asia, for that matter, including the Indian subcontinent, might have the same kind of trouble and behavior. So not only that, but we also decided to venture into something that, again, new for the GIZ, in fostering a new technology that would help the private sector in recycling the fabric scrap. We call it Fabric Waste Recycle Pilot Unit, and it's something that we basically aimed at connecting the dots of the entire supply chain of the garment industry, which is quite complicated, it's quite long. Every actor has a different role with using different technology into it, and there is a different behavior with different level of waste involved or pollutants involved. So it's not so simple as it might, it's not so easy to find a solution and to put all the supply chain together to work towards this goal. We thought of something new, and we decided to involve these particular partners that are here. So basically the GIZ acts as a coordinator that puts together the main actors of the entire supply chain, fosters the feasibility study that is required for this new technology, and then after that, of course, the private sector will do its own course of having a business out of it. The H&M Foundation particularly has funded a couple of years ago the technology, which has been invented by the HK Rita. You will hear about this technology in a few minutes after my presentation. Then we actually tied up with Dakota, that is a big garment company in Cambodia that will be involved as far as the investment, but also as far as the fabric waste is involved. We pulled in also VF Corporation, which is a huge retailer and buyer in Cambodia as well. They will take care, of course, of purchasing this fabric and retailing this fabric into their shop. This fabric, I repeat, is theoretically made out of scrap from Cambodia, and Mong is one of the main partners that are actually evaluating the project. Mong is the only actor in the country that has a co-processing plant for the waste, which is the best way at the moment of disposing the waste. But there is even a better way of disposing that waste by recycling, and they decided to actually join hands with us in this how to say, proof of technology. So 5 important actors in this initial stage of the project. This is what I was saying about connecting the dots. We, of course, will start from the garment that are producing the scraps, and we will, this technology allows the scrap to be separated between fibers and or a sort of cotton powder. So the fibers of polyester go back to the yarn producer, and the the powder that is the cotton residual into the recycled fabric is basically can go back to the fiber producer or even entire five to the cotton growers. Where can be used in agricultural projects as fertilizer, or it's not exactly a fertilizer. The material is called SAP, it's a super absorbent polymer, and it has an excellent quality of retaining humidity and water for a couple of weeks and releasing that water over the time. So essentially, this can give a better yield of cotton and a better staple length of the cotton. Essentially, we aim at connecting all the green dots, and we will also make the fabric in actually Vietnam. This will have some sort of logistical troubles, but is the nearest place where a polyester yarn spinning is actually happening in the region. So this entire project is in line with the document, with the NDC document of the non-determined contribution or strategy of the government. It's in line with the garment sector strategy that is being drafted as we speak. And the GIZ will has a role of coordinator, fostering the technology, funding the feasibility study and the market research that is behind this new technology, hence fulfilling what is the goal of our project, which is fostering sustainability in the garment sector. So I guess that was it. If anybody has some question, I am free.
Many thanks, Massi. That was really interesting. And yeah, I think the whole topic of textile waste is now really the first time in a kind of focus and approach in a structured way. And also very interesting to see which partners are now aligning with each other. And also especially interesting that Cambodia is here at the forefront of this development, finding technical solutions for the treatment of textile waste. Thanks, Massi, and I'm sure there will be also further questions later in the Q&A part. For the moment, I would like to give now the floor to Ms. Katherine Chan of the Hong Kong Research Institute of Textile and Apparel. Thank you.
I please request you to shut my presentation. I am not finding my button anymore. Sorry. Katherine,
let me see if I can grab this screen to take you off.
Thank you.
Let me see, I do this. May I ask if you are seeing my presentation?
Yes, we do, Katherine.
Okay, are you seeing the slide mode?
Yes.
Not the presenter mode, right?
The slide mode.
Great. Okay, great. Thank you. So thank you, Sebastian and Massimiliano, and for the introduction. And actually, Massi did a very interesting pre-introduction of our system, which I'll go into a little bit of detail later on. So thank you for inviting me for the event. I'm Katherine, responsible for business development in Hong Kong RITA, Hong Kong Research Institute for Textile and Apparel. So we are a Hong Kong institution for research and development for textile and apparel materials. We are established in 2006. So this year it's our 15-year anniversary. We are supported by the Hong Kong government to fund the R&D projects, and our aim is to support the textile and apparel industry in Hong Kong and also around the world. Like Massi mentioned about this collaboration that we are working on currently. that we involve global companies and also regional suppliers. So our vision is to be the leading center of excellence in research and development and also technology, focusing on textile and fashion. So what we do right now, there are a lot of research that have been going on in the textile and fashion industries, and sustainability has been a huge topic. But then I think not only recently, but then I think nowadays there are a lot of challenge on how sustainable actually that the garments are, that it's claimed that they are, right? So what we have, I mean, there are a lot of experts and scientists, engineers who worked on and spent a lot of efforts and time in making a lot of things happen. But then as we go along, consumers and the markets are more advanced, and I think they are asking more of what the suppliers need to supply into the market. So from R&D, as an R&D institution, we kind of take a step back. For what we do, our responsibility is actually not only looking at the original 3 R's, reduce, recycle, and reuse, but we look into this textile technologies in a different angle. Under this new 3 R's, reimagine, repurpose, and reinvent. This is where I think as the R&D institute that we should focus on in order to offer something that is useful and really meaningful to the markets. So our area of interest from Hong Kong Reader are materials, any new materials. Nowadays, there are so many new materials going on and still under development, and it's getting very exciting. Production process improvement, efficiency, and operational excellence. Evaluation, it means that do we need a new set of qualification and testing to evaluate the product, and then also as well as a system and the infrastructure, which we also stepping into the new IT area, such as the Industry 4.0 from Hong Kong Reader. These are the 3 main R&D pillars that we build all our projects on. The core will be sustainability. Also, we focus in making sure projects that can also benefit society. And then we add in this, we work with the industry with the new concept of Industry 4.0 with AI, big data, evaluation in the system as well. So today our focus is on managing the waste. So from Hong Kong Reader, we have worked on or created 3 technologies on textile recycling. The first one, it's a physical recycling that does not involve any wet processing, but then recycle and use garments into a brand new one. Secondly, there's a chemical methodology to recycle, or to first separate the blends, which is I would say the most popular blends in most of the garments in the markets right now. In order to properly recycle them, we need to separate those fibers in order to remake a usable garment. Besides that, we also consider using a biological method instead of a chemical one. Although the chemical one, it's not really harsh chemical that we use. We propose to use a low concentration of a green chemical in the process, which I will go into a little bit of details later on. So the first one that I mentioned is the physical recycling. It's a great concept that came from our CEO that we put together a system into a 40-foot container that can be actually built on any retail space. That process consumer or just any customer go into a shop, they want to renew and use garment that is torn, but then it's full of memories and that they want to continue to keep wearing the garment, then they can use this system and make it into a brand new one. So this is a picture of the system that is actually located in Hong Kong in one of the shopping malls in the New Territories. This is how it looks. We call it the garment to garments. It started operating in September 2018, and we are going to launch the phase 2 in the next weeks, which actually we added some new features in the system with the AI that I mentioned by processing for the last few years that we have collected certain amount of data that can help us to do the evaluation in making the fiber and the yarn more improve on the strength and also the efficiency. So what it does is it takes the garments from the consumer, and then it does a sanitizing, and then opening the garment, breaking down into pieces, and then further down into fiber. And then we spin the fiber, the loose fiber, into a yarn, and then through a 3D knitting machine that it makes a brand new garment that you can continue to wear as a brand new garment. So what I'm showing here is it's also here on this side where H&M also built this system in their Sweden headquarters. They call it the Loop, and it has won a certain amount of different awards, design awards, and also the innovation awards. So it is actually getting quite well received at the moment, because it actually let the retailers and their customers to work together in this recycle concept, that they can really get the touch and the feel, and then they are involved in the whole process of it. Secondly, it's the another facility that is sitting in Hong Kong that we collaborate with a local manufacturer. It does, you can see this actual processing line. This is the line that it does this garment sorting, and then behind it is the color sorting, which is fully automated. And then afterwards, it does this also the physical separation and respinning into yarn in the factory. Next, I want to go into a little bit of actual pictures of what these hydrothermal blend separation that Massimiliano mentioned earlier, that we are collaborating with H&F, VF, Chipmunk, Dakota, in ASEAN. So this is a process that separates cotton and polyester fibers. And this is a pilot scale of the system that is located in Hong Kong. It has the full process in separating the blended textile, so it can take in post-consumer fabric that is blended in cotton and polyester. In this hydrothermal system, we it takes about 2 to 3 hours to process. Right now at this system in Hong Kong, about half a ton a day. But we are working on an system, a more upscaled system that can process 1.5 tons a day in another country. And we're starting up the trial in the next few weeks. That we can see, but this is an existing system that's in Hong Kong that we are using every day to process post-consumer, pre-consumer textile waste, separating them, as mentioned earlier, that it separates the cotton from the textile. It makes it into a cellulosic powder that can be further processed into different applications. And then the polyester yarn would be left, remains, and then we can open it and respun it into a polyester staple yarn for further textile and garment making. So this is how it looks. So this is original fabric. It's a woven right now, but it can process any type of weave or knit fabric. After the treatment, we filter out the cellulosic powder, and then this is the polyester fiber remains to be further processed into making a new yarn. This blend separation allows lower energy consumption because we have the fiber, the polyester fiber remained from the process that can be directly further processed into new yarn without polymerization required to kind of melt the polyester and then respin it. So this is a highly efficient process. It's a kind of a roadmap how it's processed. I mentioned that this cellulosic powder can be further processed into different applications. One of them was mentioned that can be made into a SAP, super absorbent polymer, that can be used in the cotton farming right now. We're testing it out in a cotton farmland in India that actually helps because it's a SAP, so it absorbs the water and then it keeps it in the SAP, stay in the soil, and then slowly release the water as an irrigation for the cotton planting. So it helps to reduce the water consumption in cotton planting. And then we can also add in different fertilizer to make it into the powder for, it keeps fertilizing the cotton during the plantation as well. Another application of the cotton cellulosic powder is a PFC-free, a durable water repellent finish for different type of substrates. And also the third application of it is to use this cellulosic powder to be further processed into a composite fiber. So these are the different applications that I mentioned. Due to the time, I'll go through it quickly. So this is, we are at a pilot scale of this biological method in blend separation. Basically, it is similar idea in separating cotton and polyester fiber in a biological method, using enzyme material to dissolve the cotton fiber into a glucose. Then the polyester fiber would be remained in the process similar to the hydrothermal method that I mentioned. This is still in a pilot scale that we're testing because it's a biological method using enzyme to dissolve the cellulose. The time it's longer compared to the hydrothermal. So for efficiency, the hydrothermal would be the more efficient method. But then the biological method, it gives another option to this blend separation. This is a pilot scale machinery that is sitting in our lab in Hong Kong. We are working also on different ways in separating blends, working on the dry separation, also to separate multiple blends. So this is still in I would say in a lab scale process that can basically separate the different fibers by using electric charge, because if different fiber contains different charge. So this is what we are working on. Further to that, we have also other solutions besides handling waste. We have a non-discharge, no discharge dyeing machine that is built to dye synthetics and natural fiber in a closed environment, so it doesn't create any discharge. And also a CO2 absorbing t-shirts that we are working on. We have tested the proof of concept already, working on the next stage in looking into method to release the absorbed CO2 in the t-shirt. So these are just additional projects that we work on. And thank you for your time, for letting me introduce these projects to you guys.
Many thanks, Katherine, for this comprehensive presentation, especially like this garment-to-garment approach, and also the post-consumer application and the technology. And for later, I would be interested also how you would see the upscaling possibilities of those technologies, right? Yeah. Then for time being, I would like to give the floor now to Mr. Sajith of Chipmunk Ecocycle. Up to you, Sajith, please.
Okay. Thanks, Sebastian. So I'm audible, right?
Yes, you are.
Yes. So thank you very much for the opportunity. Before start the presentation, I would like to ask one question from the audience. So how much of the waste dumped in per annum? So in whole world, which is quite a difficult question to answer, because it's like not millions, it's billions. So just I will show some facts on that before I start the presentation. So you can see, so every single second you can see the tonnage are going to increase. So normally per annum, it's like a 2.2 billion waste are dumped in the world, right? So I just take a print screen, so because I cannot stop this one, and I will put into my presentation slide. Right, so we'll start the presentation. You can see my slide.
Yes, we can, Sajith.
Right. So so you can see nice dump yard, which is with a lot of plastics and things. So actually, if you look at the things with the effects of that waste dumping, there are four main issues that arise due to the waste dumping, right? So one main issue is actually pollution of our ocean. You can see 13 million tons of plastics are going to the oceans every year. So if we going like this is definitely by 2050, the plastics are much higher than the fish in the oceans. So that is one. At the same time, if you look at the air pollution, out of the nine out of 10 people are breathe air that exceed the WHO guidelines. On the same time, the pollution of soil, which is finally we are getting the as a food also. That is another major danger. On the same time, the groundwater contamination, 9,000 tons per second groundwater contamination happen. So by looking at this, actually, it's a waste crisis. It's a crisis actually. So to overcome this crisis, actually, we required some innovative solutions and things. So as a Chipmunk Ecocycle, we want to address this kind of pain points. Actually, we are not a major player, but we have to do something small, which we can, if we can get together, then we can make a large impact. So that is our business model also. We want to be sustainable to address this kind of pain points. So if you look at our activity as a Chipmunk Ecocycle, which is a waste management arm of the Chipmunk INSEE. So what we are doing is, so we are getting waste from the industries, like in Cambodia, mainly garment and footwear industry, but not only garment and footwear industry. Most of the industries we are working. So we are getting the waste from them because it's one of the major issues that they have. So, and we are bringing to our Chipmunk Ecocycle facilities, and we are pre-process those waste and pre-treat those waste. And then we are making a compatible material to the cement kiln, which is some material we are using as energy resources, and some material we are using as a raw material source. And then after that, we are disposing through the cement kiln. So that is called actually co-processing. So this is co-processing is actually globally accepted solution, right? So if you look at this co-processing solution, we can completely destroy the waste material without impacting without impacting the environment harm. So why we can do this? There are two main features there in cement kiln. One is actually the cement kiln temperature is 1800 2000, which is main burner, and all the you can see in the right hand side. What I will show you with the laser pointer. In this side, you can see this is cement kiln. It's a 72 meters long. So in the whole kiln area, mainly you can have 1450 centigrade, which is all this temperature is like a one third of sun's surface temperature. That is one of the main feature. On the second feature is actually residence time. So you can see in the gas residence time is 6 to 7 seconds, and the material residence time is like a 30 minutes, which enable us to destroy the waste completely and recover the 100% of material as well as the energy. So that's why we are saying there's a zero residue for landfill. There's no residues after we dispose the waste. And it avoids the dioxin and furan with the higher temperature, and there's no sudden cooling. So therefore, we can avoid the dioxin and furan as well. This is our solution. So if you look at the waste management hierarchy, most of the waste in Cambodia, it's going to the dump site. So it's unmanaged, right? Our solution is actually, it's superior than the incinerator. So it's going between here. It's a recovery process. It's 100% recovery of material and energy. So actually, as Massimiliano mentioned, so we are very happy to tie up with this hydrothermal process because we want to go up in the waste management hierarchy. We want to be more sustainable in our process. So that's why we are also tie up with that partnership. So we are expected to have a good collaboration and make it happen. So then, if you look at our existing solution, co-processing solution, if you compare with the conventional approach, so you can see if the cement plants are not using the waste in their cement in their process, what will happen is actually that there should be another disposal method. Example, let's say if we assume waste incineration. So then what happens is actually there are emissions happen. On the same time, finally, there will be residues also. In the normally waste incinerator, you can see 10 to 15 to 20% of residues are happening. So at the same time, we have to do cement manufacturing. Why? Cement is one of the highly used material in the world after the So concrete is the second largest material used in the world. So then we have to do cement manufacturing. Cement manufacturing process also there's emissions. So, and we are using the fossil fuel, and then finally product is cement. So what we have done is actually we have combined these two together, and then what we are doing is we are using the waste and we are processing the waste, and then we use in the cement kiln, and some of the waste we can replace our fossil fuels, which reduce the emissions of fossil fuels. On the same time, then we are managing our emissions within our limits, and finally we are making the cement. So this is one of the good example for the circularity, right? So this is one of the good examples, and this technology for the Cambodia, it's only 1.5 years we are using, but in the world it's a 40-50 years other cement plant using it, especially in the Europe, Japan, US, those countries are using this is 30-40 years now. Even now Vietnam, Thailand, our neighboring countries also use it. So our approach, we have a 6-pillar approach. As a Chipmunk Ecocycle, we have a 6-pillar approach. One is actually circular economy, right? So everybody's are talking about circular economy, and it's a key topic for these days. On the same time, if you look at the industries are also struggling because they have sustainability ambitions and all these circular targets, but they're struggling to make this happen. So what we are doing is actually we are working with these stakeholders and to find some more sustainable solution for their waste and turn it into the circular resources and divert this waste from the landfills. That is one of the key approach what we are doing. On the same time, the industrial symbiosis. So today, Ecocycle builds industrial symbiosis with the many industries like garment and footwear industry, wooden industry, agriculture, or you name it. Most of the industries we are working at the moment. So that is another part. And sustainability. This is one of the DNA of us. So we want to make a better planet to our future generation, and health and safety. So if we are going to handle that waste, mainly with the hazardous waste, we have to be very careful. We have to be very vigorous on this, and we are focusing more on this. And we are looking at our employees, not only employees from our contractors and our other partners. Every aspect we are looking in this part. And next one is a regulatory compliance. We are compliant to the local regulations as well as the international regulations, because we have a what we call well-defined internal risk management and compliance management systems. On the same time, last one is a partnering. So we are partnering with the communities, we are partnering with the customers, we are partnering with the international organizations like GIZ and things. So that is our approach.
Sajith, there is one immediate question addressed by Massi. The question is, how much more capacity can you accommodate in terms of metric tons of waste in your co-processing plants?
Actually, I will answer that question from the next slide.
Right. Okay, perfect. Thank you.
So this one actually, what are the waste that we can dispose in cement kiln? So the industrial waste, if you look at the industrial waste, 95% of the industrial waste which we can dispose in the cement kiln. So if I answer to the next question, currently we have a capacity of 75,000 tons capacity is there, and we are going to upgrade into 150,000 tons, which is, if you look at the Cambodia waste, industrial waste, it's like a 40% of the Cambodia waste. If we can bring all waste, 40 to 50% of the Cambodia industrial waste, we can accommodate to the co-process. So at the moment, this 75,000 also, we are getting like a 40, we are running at a 50% capacity. So, but we are very, at the moment, we are getting very fast growth in the volume wise also. So if you look at the customer wise, we have more than 80 customers now, because our lifespan is only, if you look at our history is only 20 months. Within 20 months, we have 80 factories, more than 80 factories we are working with us. And we are replacing 15% of our fossil fuel from that waste. And we are reducing like now, as at August, like 94,000 kilotons of CO2. and we have co-processed 80,000, roughly 80,000 tons, kilotons, 80 kilotons, and we have invested $6 million only for the waste management part, and further we are going to expand this one. This is some numbers, and if you look at our journey, we start 2019 December with the presence of His Excellency our Minister of Environment. And then we started the non-hazardous waste, agriculture waste and non-hazardous waste. And then within 3-4 months, we moved the hazardous waste. We are using sludges, we are using pharmaceutical waste and things. And we have a lot of collaborations with special economic zones. And we have a signed MOU with footwear associations. And we have a signed we have a signed MOU with the Ministry of Environment. Now we recently joined hand with this hydrothermal process. Likewise, we are doing going quite fast on this one. So this is one of the examples that I can show during the, because in this session most of the people will talk about the garments, right? So if you look at the garment and footwear industry, actually at the moment we have 43 customers, 43 factories are contracted with us. So what we are doing is actually we are getting the waste and then we pre-process and then we are used in our cement kiln. So we are giving the zero residue for landfill solution for them at the moment. So if you look at the customer wise, most of the multinationals, most of the fashion brands are working with us. Not only fashion brands, some special economic zones, some you can see our gold mining companies and British American Tobacco and paint companies and pharmaceutical, you name it, most of the multinationals are working with us because they have a sustainability ambitions. We are working together to achieve those things. So just before finish the presentation, I would like to show you again the same numbers which I shown previously. So now I again take the print screen and put it into my presentation. I think I have a technical issue. You can see I think I have a technical issue. By looking at the numbers, you can see it's quite what do you call? It's quite alarming. It's quite alarming that the waste generations and waste dumping to the landfills actually we cannot count. It's millions of tons are generating per day. So 2.2 million tons are dumping means it's like millions of tons are dumping. So there is we have to act quickly and we have to give a proposed solution and we have to get together and make some innovative solution. Thank you very much.
Also for underline the urgency also to find solutions and also the magnitude of this crisis. And I always find RDF and co-processing a very good example for a win-win situation. On the one hand, the cement kiln gets the energy that it needs. It does not depend only on fossil fuels, as you said. And on the other hand, you are providing a solution for large quantities of waste that would otherwise go to landfill. And as you said, in Europe, it's already a concept that is very successful for decades. And it's impressive now to see that also Cambodia is going this successful path with Chipmunk being a leader there in this field. Thank you again. Now I would like to hand over the presentation to Mr. Rolf Keil from EUWELLE, please. The floor is yours, Rolf. Thank you.
Yeah, hello, everybody. I hope you can hear me okay. My name is Rolf Keil. and I will give you an introduction of one of the technologies that Sajith was just talking about, namely the innovative technologies that are required for countries like Cambodia in two ways. In the first way, it is technology that is designed, tailor-made to treat the original waste streams, municipal and industrial, that come together in a country like Cambodia with a specific composition, like a high moisture content, lots of organics and so forth. And on the other side, it is a technology that has been developed and been patented in Germany many years ago, like Sajith also mentioned. So it's nothing really new around the world, but it is new to Southeast Asia and Cambodia in particular. So I will try to find the screen and show you my slides. Give me a second, please.
If you have challenges, Rolf, I can also share your presentation from my screen if it's easier for you. Now we can see it. Okay, great. We can see it
now, yeah?
Yeah, yes.
All right, brilliant. So thanks again for joining us. My name I mentioned already. The company that we are working with here is EUWELLE from Germany. And the technology that I'm talking about to you today is called MYT. It's maximum yield technology. And as I mentioned before, it has been developed tailor-made for the circumstances in Southeast Asia. So you will find a lot of relevance for it. I would like to start with a good reference in the neighborhood where we are now, down in Jakarta. You may have heard about the Nambo project. It's quite a pioneering project, and in this sense, it is it's very relevant for the situation in Cambodia. Jakarta has very similar challenges with the waste and the environment as Cambodia does have. It's a much bigger nation, and still it has taken so many years for the first plant to come into life. We are currently starting to prepare building this plant. I give you a little bit of a background of the MYT in Nambo. The process is fairly simple, and I always use the example of cooking something. It appears quite simple, but it needs a lot of knowledge to cook the right meal. I'm sure you can relate to that. The process really is two steps. It is a mechanical treatment in which we take out RDF1. It's a very high calorific part of the in general waste. And we split it from other recyclables. And then we go into a second step, which is a biological treatment, in which we extract more RDF that we blend, which is called RDF2. So we have a bio-based RDF and a fossil oil-based, if you want, so with a lot of plastics. But we don't stop there. Sajith was mentioning our joint ambition to divert waste from the landfills and the environment. So we're taking out full inerts and other recyclables, and we are actually producing compost, fertilizer, and electricity from it. So our plant doesn't need electricity or water. We produce it, and we can live from the treated leachate that comes out of the very moist waste that we treat on those sites. This is a list of projects that we have done around the world, including many in China, next door in Bangkok, in Thailand, the Onnut plant, which is running already since a few years, and obviously the first one dating back to 2006 in Germany. The Nambo project itself, to give you a bit of an idea about mass balance, how does that look? You can see that we are actually removing most of the wastes, and we are putting nearly less than 5 to 6% back into the landfill. I'm not an engineer, as you may hear from my talking, so I would like to show you a bit of a video, quick video with an explanation of how such a plant can work. What you need to keep in mind that EUWELLE acts here not only as the equipment supplier and manufacturer, but also as the developer, investor, and operator of such plants under concessionary agreements. It means I'm not here.
Rolf, could you make the full screen, please? It's still in slide mode.
Yeah,
we can see this better.
Better like this, yeah. Okay. I mean, the slides will certainly be made available to everybody later on.
Now it's better. Yes, thanks, Rolf. Yeah.
Okay, cool. So allow me to quickly share you the video. That's why maybe I put it smaller. Just a second. Now I need to manage that. Stop share. Here we go. Okay. Let me make that big and start it for you. I hope it comes okay with the sound for everybody.
Rolf, I'm not hearing any sound. If there's sound intended, I don't think it's audible.
Could you check if it's on mute, Rolf, or if it's just the internet, then we not have a chance. So I think it doesn't really work, Rolf. And unfortunately, it was a nice try, but I think it does not give so much information at the moment. So the screen is more or less stuck. Ah, okay, now it's moving. Okay, let's give it a few more minutes. Right. Okay, now it works, but still not audible. Thank you, Rolf. So unfortunately, the video is without sound, but I think we got some really good impressions, at least some pictures that we have seen. Those are pictures from the plant in Germany. I've also visited the plant, I've seen it. And what I liked with the MYT technology, that it's possible to transfer high technology, high German technology into an Asian, Southeast Asian context. As you mentioned, you already have references that are implemented in Thailand. You are building now one of the largest mechanical biological treatment plants in the world in Indonesia. So it's another very good example of practical implementation, and also interesting to understand that you're looking into the Cambodian market also to set up facilities like what we have seen before. Do you have further slides also, Rolf? We are a bit short on time, but
yeah.
If you have further important
if you allow me,
Sure.
Sorry for the mishap with the video. We will certainly share the link. It's available on YouTube channel. Our engineer, Ms. Hoa, will take you a little bit through the details of the process right now to finish the slides, and then we will be ready for the Q&A afterwards. Again, my apologies for the mishap with the video sound. Hoa, please.
No worries. Thank you. Thank you.
Hoa, you need to switch on your microphone, please.
Thank you, Rolf, and hi everyone. So let me explain a little bit more about the MYT technology that is unmoved from the video. So our MYT technology is a patented technology designed in Germany for unsorted waste, and it includes about five steps. From the step 1, where we will receive the waste, and then mechanical pre-treatment with separate the mineral, metals, recycle, and also produce RDF1. That I can explain a little bit later. And then it's go to the biological step. In the biological step, the waste will be hydrolysis in the multi-zone reactor, and after about 2 or 3 days in the reactor, the waste was a little bit homogenized, reduced in size, washing out of chloride and many other things. And then it was going to the dewater press. Next, we will have wastewater treatment to produce the biogas to make electricity. And then the remaining waste will go into the biological drying, that we will make the RDF2 with a different classification, satisfy the different demand from cement industry, paper industry, boiler industry. And here, from this slide, that you can see that we make a comparison between our RTF and the core. In the image you see here is a different type of RDF with different in size, in calorific values. Normally, the calorific value of the RDF from waste produced by MYT technology will be in range from 11 to 16 or 18 megajoule per kilogram. And compared to the core, actually, our RDF has a cheaper price compared to core, and the calorific value is satisfied to cement industries or paper industry. The water content in the RDF can be adjustable, depends on the customer design. It can be about 10 to 20 to 40%, it depends. And the sulfur, the chloride content is maintained lower than 1%. The ash content is maybe another problem with the amount about 30%, but that one, for example, in the cement industry, the ash content will be linked into the clinkers, so that is no problem. From this slide, we can see that there is a different calorific, different classification of RDF and SRF that are suitable for the coal power station or the calciner from the boilers in the cement kiln. And the difference, the variety from the calorific values as well as the particle size and the chlorine ash content is all differ from each demand of the industry. But our MYT technology can produce, so such kind of RDF quality depends on the customer demand. And our technology is flexible and adaptable to produce the suitable quality. From this slide, you can see that the MYT technology can, from the waste, we can produce RDF, not only RDF, but biogas, the treated water, and then the other things like mineral, metal, residual that are after the mechanical pretreatment. In the MYT plant that we have in Germany, actually with the waste amount about 100,000 tons of waste per annual, we can produce the energy with amount of 235,000 megawatt per annual. And from this diagram, you can see that RDF is the most benefit product that we can produce from the waste, which is about 70% of the energy. And also biogas is the next one. And its MYT plant consume about only 11% of the energy it can produce. So our MYT plants produce our own energy, and also we produce energy to sell to the grid. In number project, not only RDF, but we produce compost. And the compost, our compost quality is satisfied with the requirement of the local Indonesia company from the organic content, CNA ratio, or the total NPK content, as well as the heavy metals. In general, from the video, maybe you can miss some information, but in general, we can say that the MYT plant is a very effective technology to treat unsorted waste, and the energy in the waste was utilized into the fuel like RDF that we can use in cement industry, in the paper industry, and the treated water can be reused or discharged to the environment, and other recyclable things like metal, minerals that we can reuse. And this technology is really effective in reduction of waste amount to be landfill, and its prevention of the landfill gas emission, of course. As you know, in some landfill in the developing countries, sometimes there are fire because of the methane gas. So with this technology, the things will be limited. And also the ecological and economical utilization of energy content and valuable that you can see from our diagram of technology. First, the most benefit will be RDF. The second will be the biogas, which produce electricity for self-consuming and also produce electricity for selling to the grid. The third one is the treated water that can be reused and discharged to the environment. And other is recycling, and residual will be go to landfill.
Yeah. Well, we have to come to an end. Unfortunately, it's very interesting. We would love to listen more, but unfortunately, we have a bit of a time constraint already. Yeah. Maybe we can shift a part to the question and answer session. Also, I'm sure that will. Actually, so it's the last one. Oh, okay.
Yeah,
great.
The last one actually. Yeah.
All right. Thanks a lot, Hua. Thanks, Rolf, for that. And without further ado, I would like to give again the microphone back to Sajith, please, because he has also a short further presentation. Over to you, Sajith, please.
Yeah. Yeah, you can see my presentation, right?
Yes, we can.
Yeah, right. So I just, within 5 minutes, I will finish the presentation. So I think Rolf and Ho has explained about this process of making the RDF, mainly from this municipal solid waste, right? So what we are doing is, because we have a sustainable ambitions as a cement player, right? So we want to reduce our CO2 footprint and things. So therefore, we want to drive our cement greener, more greener. So then this substitution of a fossil fuel is one of the key topic for us. So that's why this RDF concept is very, very important for us. So therefore, to achieve our sustainable ambition target in 2030, which we have already made commitment to our shareholders. So we want to, if we want to sustain this, RDF is one of the key thing that we want to take into account. So if you look at in perspective of the sustainability triple bottom line, it's perfectly fit with our agenda. Why I am saying that? Because as mentioned by Ho and Rolf, so it helps us to reduce the fossil fuel usage. That means coal, mainly fossil fuel, what we are using is coal. So that helps us to reduce our fossil fuel usage. On the same time, environment performance side, as mentioned, yes, there are reducing the greenhouse gases, which is if this waste is in the landfills, then there will be an emission, methane and those kind of things. So on the same time, our direct emission reduction will happen with our coal reduction of our fossil fuels. So that is another part. And our technology, in the co-processing technology, we can use this one as a safe and optimal treatment method. And as mentioned by Ho also, it will help to the whole society to reduce their lifetime of landfill extension. We can increase the landfill lifetime. And the social responsibility, basically, if you look at it's a main crisis. So we can contribute for the main crisis. Another thing is, so if we can use in the cement kiln, so therefore the investment wise, the public funds for the waste to energy or other incinerations are less. So then job creations happen and livelihood, especially the landfill side, all the neighboring people livelihood will be improved. That's why it's a sustainable thing. But so when we are using this in cement kiln, there are several challenges that we have. But as a company, but this is not only in Cambodia, everywhere, most of the places they are using this RDF. So, but there are several challenges we have to overcome as a cement player. So one is actually the quality challenges. So the moisture will be one challenge, and chloride will be one challenge for our cement process. So which we have to have very engineered process to manage this one. So therefore our people, so one thing is the RDF maker, supplier, or RDF investor who are going to do that is one part. And at the same time, cement plant people also has to be very keen on this. And the logistics wise also quite challenging, because normally these main landfills are normally not close to the cement plants and things. There are these waste are quite low density materials, and the storage wise, if there's a cement plant shutdowns and things, then storage wise also we require high investments to that. And the coal price, because mainly this one is benchmarked with the coal prices. So the prices are fluctuating. Last year, actually, coal price goes to rock bottom, and then the most of the cement players are struggling to use the RDF, and especially the RDF suppliers also. But that is one aspect. And the other thing is the mindset change. So when in this part of the world, this part of the countries, developing countries, the people knowledge is not quite limited especially in the technical front. So that when we are using this waste in the cement kilns, and then people can have a misperceptions with the cement qualities and things, which is not happen, but the normally in the majority public can happen like that, but it is not the fact. And the investment there is, we require some considerable investment. But all these key drivers are important. We know that. So, but we are happy to engage and happy to work on this and make our sustainable ambitions true. So thank you very much. So I think if you have any questions, I can answer during the Q&A session.
Many thanks again, Dr. Sajith. I think now we have nearly 20 minutes left, and I would like to also give some room for the question and answers. That's why my slides will be very short, but still I would like to show this because we have heard some very interesting input about innovative recycling technologies, but the session also actually is called Suitable Financing Tools. And that's why I would like just in 5 minutes show you also some ideas that are discussed a lot outside Europe. That's the concept called EPR. That's one of the key financial or financing tools for the financing of collection and treatment of municipal solid waste. And yeah, so I would refer to the German model. So the one question is how Germany reached high recovery rates and created a circular economy, and how this could be adapted in a Cambodian context. So first of all, shortly about our company, BlackForest Solutions. We are active worldwide, providing solutions for all sorts of waste management problems. We have worked in more than 60 countries, and one element or one concept that we are analyzing and supporting is the concept of EPR. Also together with GIZ, currently we are providing the development of EPR solutions for packaging waste in Egypt, Algeria, Vietnam, Philippines, Indonesia, Thailand, China, and also other countries. And what is important to understand also in a Cambodian context, when you look at Germany, it all started with legislation. So first of all, there should be a proper legal framework in place. And I know that there's a very intensive discussion also in Cambodia about the topic of the so-called extended producer responsibility. That means that the company that distributes certain products that are packed, they are also responsible later for the product once it became end of life. So that means once it became a waste. And responsible here means that the distributor and the seller of this packaging needs to finance, needs to pay for the collection and for the treatment of the waste streams. And the second milestone in Germany, legal milestone, was in 2005, where Germany banned any landfill for untreated waste. And this is also where the technologies really accelerated that we have seen just now from Mong, from Dr. Sajith, but also from Hua and from Rolf, a mechanical biological treatment and the production of refuse-derived fuel. This all was further accelerated after the ban of landfills in 2005, because you can imagine, as long as the landfills are still in operation, it's very difficult to also implement innovative treatment technologies, yeah, because landfills are just cheaper than operating innovative treatment technology. That's why the legislation is an important point also for Cambodia. In Germany, it led to the development of different technologies, as I said, and as of today, also in Europe, waste-to-energy concepts, they play an important role. And within the waste-to-energy concepts, especially the concept of RDF and of using larger quantities as an RDF, as a refuse-derived fuel in cement industry. So Sajith put a few numbers there. In Germany, we are now about 70% substitution rate. That means that the cement kilns are using 70% of their energy from waste at the moment. And also one important point is that when we are creating circular economy and treatment technologies, when we are closing landfills, this actually leads to this word of circular economy in the sense of that there are companies founded. Yeah, so there are 11,000 companies in Germany, 270,000 people working directly in waste management. These are all jobs. This is all income. Taxes are being paid by these jobs. So it's in the true sense a circular economy. Also, in Germany we have a turnover of waste management companies of about 70 billion euros. Yeah, and you see also some numbers in Germany about the amount of waste that are generated every year and how it was possible to achieve those high recycling rates. Yeah, and I would go straight to this slide here because the extended producer responsibility you see here at the bottom left contributed 1.2 billion euros every year in Germany for the infrastructure of waste management. That means for the collection and for the treatment and for the operation of those technologies that we have just seen in this session before. And besides EPR, there are also other income sources. It's always a different mix of financing tools, but EPR is certainly something where we see this works all over the world. It's now a momentum there that this concept is taken very serious by the countries, including Southeast Asia, and that would be certainly also a concept for Cambodia to further finance innovative treatment technologies. Besides this, we can talk about also subsidies or charges and tipping fees. But the whole financing models are shown here on this slide, and also all the presentations will be shared among the participants because there's a lot more to say. But at least I wanted to show you this slide where you can see how waste management can be financed with those tools itself. And it's not EPR actually a burden. Yeah, it is affordable. You see here on this slide, the actual products then that are packed are not getting significantly more expensive. Yeah, so we're talking about the majority less than 0.2% of the actual product price. Yeah, and with this less than 0.2%, you can actually contribute significantly to the collection and treatment of waste. Maybe this in very short form, because I wanted to use the last 10-15 minutes for the exchange and to also come to a dialogue. Maybe you have further questions. I would have a few questions to the participants, but maybe we can start with the audience. Do you have any specific questions to one of the presentations that you have seen today afternoon, please? If that's not the case, or if you need more time maybe to write or to think, I would have one question, first of all, to Katherine. So we have seen some of the technologies that you have presented about the treatment of textile waste. How would you see the situation for the upscaling? So how can you achieve more quantities? What could be a suitable throughput for this? And what are the challenges for the upscaling?
Yeah, right now the biggest challenge that we see is the sorting part, because if we want to handle post-consumer textile waste, there are just various uncontrollable mixture of different materials, and it makes it quite difficult if we want to do this blend separation before upcycling. Currently the option that we see is using this dry process, which I mentioned, the G2G, or a more upscaled or industrial scale. Right now in Hong Kong is doing this dry process, sanitizing the post-consumer waste, and then opening and respinning the fiber. But then the thing is, it will be difficult to control the quality of the yarn because of the multiple variety of the input materials. So this is where we need to continue to work on in controlling that.
Understand. All right.
Yeah.
Okay. Thank you, Katherine.
You're welcome.
Maybe one question to Massi, please. So also, when you think about the overall concept of the collection and the treatment of textile waste, how would you see a financing tool of EPR, for example? Would you think that's a possible concept, that collection and treatment of textile waste could be financed by an EPR mechanism?
I think there is definitely a possibility of such financing. Maybe not everybody knows, but the GIZ as well has a financing tool. They call it DPP development. It's a system that basically works half financed by GIZ and half financed by the private sector. And this can be applied, the private sector can apply for this kind of financing due to a certain conditions. If the technology is new and there is no competition in the country, the private sector is welcome in GIZ to actually apply for this kind of tools. We do not exclude also the possibility in the future of having an IBPP even for the green machine in Cambodia later on, yes. Because technology is new, there is no competition. The GIZ would not finance something that would hurt the competition. It's the very first into the country. The technology needs to be proven at the even bigger scale than what we are going now. Therefore, there might be a possibility of doing this. Thank you.
All right. Okay. Thanks, Massi. And maybe one question to Sajith also. That was part of the chat. So how do you see the possibility to also treat hazardous waste in your rotary kiln? So what are the opportunities and what are the challenges of industrial hazardous waste?
Yeah. Basically, now we are using the hazardous waste, but mainly at the moment actually. Technically, most of the hazardous waste we can process in cement kiln. Challenges comes with the what we call the collections fees, right? Because the waste market is very immature, and then this is the what we call the Cambodia used for the dumping the waste. So then we are going to turn as a first player who came as a sustainable player for the what we call as a larger scale. So then we have a challenge of getting the things with the right collection fee, because it has a cost. It has a logistic cost, it has a processing cost and things, and we have to do it in a very safe manner. So in order to make it very compliant way, it has a cost. So to turn from the dump, what we call, from immature to the mature level, that is the major challenge. Otherwise, the cement kilns are quite capable to handle most of the hazardous waste.
Yeah, I think one has to know that in Cambodia, there is currently, so far as I know, not really a larger treatment facility for hazardous waste available, right? And when you look at the German context or the European situation, then hazardous waste is treated in special facilities, but those special facilities, the incinerators, are very close to what happens actually in a cement kiln. That's also a rotating kiln that is continuously fed, and the similarities are very close, between a hazardous waste rotary kiln and the cement kiln. That's why it's perfectly suitable for hazardous waste when it has, of course, the right flue gas treatment. Right, the flue gas treatment is crucial for the processing of hazardous waste. But I think also here Mong has already done investment to improve and to upscale also their flue gas treatment. Right. Yeah.
And other thing is, if you look at the number wise also, now we are treating like 300 tons per month of hazardous waste roughly, which is including sludges also. At the same time, our partnering countries, sorry, our sister companies are doing more than 3,000, 4,000 tons per month.
Per month, yeah.
Thailand, Vietnam, and Sri Lanka, they are doing much higher scale.
Right. Okay, Christoph, you have a question, please.
Yes, thank you. That would be actually a question directly to you. So just a practical maybe question. If the Cambodian government decided to adopt extended producer responsibility, what would be the first steps? Would you first, I assume, make a plan or make a law, or how could they go about this?
Yeah, there should be really, first of all, a law, because this is a legal concept. Without legal regulations, the brands would not fully be available for an EPR concept according to our experience. There are some voluntary possibilities, some voluntary options, but it works more if there's a very clear law. And when you see at the neighboring countries at the moment, I would say for Southeast Asia, Vietnam is one of the most developed in terms of EPR regulations. They are very close so before finalizing an EPR regulation that will be also, in our opinion, effective and efficient. And it's in the end a proven concept. I mentioned this figure 1991. This is something that is being executed since 30 years. What it means is there's experience already. And we are at the same time also in countries like Algeria, for example, or Egypt. And we see that this is very much possible to implement such a concept and a regulation, first of all, in low and middle income countries. After this, you would need to have an organization called PRO. That's the Producer Responsibility Organization that has the purpose or the task to implement EPR concepts. So there are organizations that are available to implement this. I'm currently based in India, as I said. India has just ratified EPR like 3, 4, 5 years ago, depending on where you see the definition. But within 5 years, India has accelerated a lot in this for this topic. Now there are more than 100 PROs in India within 3 or 4 years. So this again shows how much or how this is really possible. Maybe one question to Rolf also, please. How do you see the financing of the treatment of your facilities? So I've also showed in the financing tools a few potential income, but maybe could you please explain to the audience what are the necessary income sources to operate a facility that you have shown to us?
Yeah, thank you for that. It's an important part of the whole venture, of course. You named it already for the EPR, that we're taking benefit in many countries that are reached to that level already. That's an important revenue stream because it alleviates the necessity for the municipality to pay a gate fee or a higher gate fee than they can afford sustainably. And in my world, personally and professionally, this is a very, very important aspect, because without it, and now I come to answer your question, we need to rely on those revenue streams from the municipality to pay a tipping or gate fee, which makes it nearly impossible for lesser fortune or rich provinces or societies or parts of a country to be able to afford and enjoy the luxuries of a comprehensive waste treatment facility that converts the waste in a meaningful manner beyond throwing it in the river or dumping it behind the tree or the landfill or whatever you have. The other revenues, fortunately, come from the industrial sector, where we do business-to-business agreements. This could be with the cement industry, for example, like Mong in Cambodia, that pay us for an agreed supply quantity and quality of RDF, alternative fuels, to substitute their coal requirements. And using such a refined RDF also obviously bodes much better in the carbon footprint than just trying to use pretty much directly industrial waste. And this is a known, but it is a very good step towards it. As you have seen in our slides, there's also other products that we produce in the MYT process. And this is, for example, granule fertilizer. You know, in Cambodia, you have neighboring countries like Vietnam and Thailand that are actually exporting granule fertilizer to the neighborhood in Indonesia, for example. So you actually, aside from only using it inside the country, it can become an export revenue creator. So we have a good footprint. We put our eggs and the risk in various baskets. But I come back to what your topic is, Sebastian. To have extended producer responsibility is, in my world, really the fairest way of taxation, if you want to, or distributing the load of those revenue streams to the actual people and parts of society that use it. So it's actually an opportunity in itself. So this is how we finance it. Obviously, then it is going all the way to your standard project finance, where we're taking major loans and project finance instruments from mainly institutional lenders like IFC and ADB. And obviously, we're also trying to support the work that BFS is doing in Cambodia and other countries by helping to work as a producer and plant operator with the feasibility studies to generate and reach the level of those laws like we have it in Germany since so many years. Because the interesting part is, of course, you may be able to publish any kind of law that you want in terms of diverting the waste from the landfill or elsewhere. But if you do not have a plant to actually treat it in that foreseen manner, it is purely a decorative activity. So it is important and to have manufacturers around the table from day zero, like we do it today. That's why I really enjoy this opportunity. And apologies again for the video with no sound. Okay, thank you.
All right. Yeah, so now we have officially we reached, I think, the time limit. I don't know if there are some further questions from the audience, from the participants. If not, I would have maybe a last question. So Massi, you mentioned the Develop PP program of GIZ also, and there are other organizations involved. This would be for actually financing, for example, a facility that was introduced by Katherine, that is in terms of how to build technologies and how to treat treat the waste. This could be initiated by such a funding opportunity. But how would you see actually, I mean, how to finance the collection also, how to do the collection of post-consumer textile waste? Yeah, because what Rolf just said, I mean, the word taxation, yeah, so it's maybe not considered as a tax, but it works a bit like a tax, that the one who produces, for example, this bottle, I can know if you see it, no, you cannot, I just have a bottle here, but that the one who produces something, also a t-shirt, you know, or textile or fashion, that this could be taxed in a way. and this money could be then used for the collection and for the treatment also. This would be one question, maybe also to Katherine and to Massi. I don't know, how would you see this one? Are the brands ready for this? Because there's also one risk that Katherine mentioned, this of greenwashing, right? That some brands are saying we want to do something, but when it comes then to the real action, the question is, are they also ready to pay something for the collection of the waste that they are actually generating? This is a question to Katherine and to Massi, to both of you, please.
Okay. Katherine, go ahead.
Yeah, so from our experience, I think the brands are also they are definitely very eager to be able to do anything. Yeah, but then I think that's why we are still in a quite early stage, that we have to work hand in hand and figure out how the best implementation, how to process it. Whether they are willing to pay, I think this is actually not in the consideration right now. The more critical part is it's how to figure a workable way that can be done in an industrial scale. That figure out each parties who are the participants in the supply chain and make this process work. I think as soon as we figure it out, then we will look into whether, I think everyone so far from my conversations, the financial part has never come up as a concern. So definitely, I think it's a great urge and eagerness from the retailers. That's how I see. I don't know if you see also the same, Massimiliano.
So I have a very practical spirit, and this comes mostly across because I come from 20 years experience of purchasing garments abroad in Southeast Asia, in the South Indian subcontinent, and shipping them to Europe. I think the problem of post-consumer is something related with more evolved market, bigger wallet availability, and rather the problem affects Africa in a hugely bigger manner than what is Southeast Asia affected. Because all those second-hand garments ends up in Africa, and only 10% is used of what arrives, and the rest is completely dumped. So therefore, post-consumer recycling technique and funding a way of addressing the problem by taxation can work in an economy that is able to address the taxes and to make the taxpayers accountable for those taxes. In Southeast Asia, in India, in Bangladesh, I don't see it happening. And at the same time, these economies are not so much affected by the post-consumer like other countries, as I said. At the same time, European brands are just buying in these economies, and they're not releasing into the market their garments. They're rather buying them. So it's probably in China there is a lot to do in this meaning, but in Cambodia, Vietnam, partially, Myanmar certainly not, Indonesia a little bit. In the sense, we are not yet there. What we have to, therefore, we address the issue from the post-industrial fabric waste. That was our approach because of the practicality that I said before.
Noted. Okay. Thank you for this view. Christoph, what do you think? Shall we conclude the session, or would you like to have some last words? Or
yeah, I think we're a little over time already, and it's Friday evening, so I think we should leave everybody to enjoy their weekend. But on that note, I would like indeed to add something. The Waste Summit, as you probably know, is for 3 days. So tomorrow is the 3rd day. So I would encourage everybody to also join us tomorrow. Of course, if you're located in Europe, it's a little early, 4 a.m. But if you're in Asia or in Cambodia, it's 9 a.m. Tomorrow. We have a training on organic waste recycling, on composting. So there's a practical demonstration video live. We also have something very interesting, which is, you probably have noticed there's an exhibitor section on our Waste Summit website. So these companies and institutions will also have the chance tomorrow to present themselves. So if you saw a very interesting organization that you would like to know more about, there's a chance that they will actually be talking tomorrow about their organization. So on that note, I hope to see you again tomorrow. And if not, then please enjoy your weekend. And I think with this, I would like to close the session. And of course, I would like to thank everybody. We had a very long day, a lot of input. So thank you, Sebastian, for the moderation. Thank you, dear speakers. It was a true pleasure today, and goodbye.
Thank you.
Bye-bye, everyone.
Bye-bye.